Hello and welcome to Web Development 101 with Alex Merced. On this show, we'll talk about all the basic concepts of web development in a way that anyone can understand, whether it's front-end web development, back-end web development, and full-stack web development. If you're new to web development, I recommend listening from episode 1 to understand all the concepts from beginning to end. You can also learn more about my own personal projects over there at alexmercedcoder.com. Thank you. Hey everybody, this is Alex Merced and you're listening to Web Development 101. Okay, over the last few episodes we kind of discussed sort of the basic web development technologies. So again, that's the idea of what does a browser interpret? So what can someone from the internet or some other server send to your client browser and a browser interpret? And for the most part, we talked about HTML, which kind of does the structure of your website, the CSS, which does sort of the style and appearance of your website, and the JavaScript, which kind of describes the behavior on the client side of your website. But what I didn't mention yet was something that's kind of new. Okay, so over the last couple of years, pretty much all the main web browsers have adopted a fourth technology that it can render into your browser. And that technology is called Webassembly. Now, the idea behind Webassembly is to create... Now, when it comes to programming, there's machine language. It says all the zeros and ones. That's pretty much what your computer really interprets. So at the end of the day, everything has to get to machine language, all those ones and zeros, for your computer to kind of know what it's doing. Generally, the next sort of step up was assembly language, where you had sort of byte code, where basically each code took up sort of 1 byte, or each piece of byte code. Now, if you ever read assembly, it's not like reading modern day programming languages where you can kind of know what's going on because the words are like words you know. It's all like X's and numbers and letters and all sorts of really weird random ways. So the problem is, even though assembly is a little bit easier than machine language, just zeros and ones, it's still not something that you want to be programming manually in. That's why all the other programming languages kind of got built on top of things like assembly and machine language. Okay, so basically, the way you got to think about it is that every programming language kind of took you one step closer to something that's resembled more like natural speaking, simpler instructions. Okay, so that's what they mean by sort of higher and lower level. So lower level means closer to machine language. Higher level means, you know, there's more sort of intermediary steps. So WebAssembly is more like assembly in the sense that it's very low level. So it's almost like you're going to sort of machine language. So the idea is, instead of using, if you could compile something into assembly or WebAssembly, your browser can read WebAssembly and it'll run a lot faster because it's a low-level language. It's going to run more efficiently because when you're programming something in a lower-level language, you can manage the memory better, you know, really kind of customize it to your specific application as far as the way memory is managed, stuff like that. But this opens up a whole new world of possibilities because traditionally, again, the only languages that your browser knew was HTML, CSS, and JavaScript. So when it came to front-end development, meaning, you know, what you see on the website, your user experience, your user interface, basically those were the three things you had to use. So everybody had to learn JavaScript. Some people love JavaScript, some people hate JavaScript, and they'd rather be able to program in the language of their choice, whether that be like Erlang, C#, Python, Ruby. But you couldn't really do that, okay? You had to go through JavaScript. So you either learn JavaScript or people would create what's called a transpiler that took your code in a different language and turned it into JavaScript. But JavaScript is already kind of a high-level language, so that sort of adding that extra step wasn't necessarily the most as efficient as if you just did the JavaScript yourself. And again, JavaScript is not, again, it's still a higher level language, so you're not getting close to that assembly level efficiency, in a sense. So you could do that, and people do that, and it's a totally viable, works well, especially with everything, so much internet being faster, computers processing being faster. A lot of these issues matter less than they used to, but it was still a concern. So this means now people can create compilers that compile to WebAssembly and allow you to use other programming languages directly in the front end. So you don't have to use that intermediary step of JavaScript anymore for your programming language. So right now you have several different programming languages that are creating these sort of WebAssembly compilers. Right now, when it comes to Microsoft, so Microsoft has the .NET Framework, which comprises of 3 programming languages, F#, C#, and VB.NET, which I'll talk more about the .NET Framework in its own episode. But what they're doing is they're creating a framework called Blazor. So from now on, instead of, doing your back-end server stuff with .NET and then using JavaScript, HTML, CSS to design the appearance and function or user experience of your website, you can now just cut through that and do it all in C#, F#, or VB.NET. Okay. And the way they did it is pretty interesting because, again, creating a compiler takes time. I mean, basically, what a compiler is doing is basically taking your code and then figuring out what does that look like as the target language. So in this case, WebAssembly. And that takes a long time to make sure everything is covered, that every possibility of how that language works is factored into that compiler, so that way when it compiles your code, it compiles it right. Because once it's compiled, you're not going to be able to look through the compiled code and debug it unless you've learned how to read WebAssembly or machine language, which, well, that's tough. Okay? Not for the faint of heart. So that takes some time. So they had a really interesting intermediary step. So instead of trying to figure out how to create, well, they are trying to create a compiler that will compile .NET code into the browser. They've actually created an intermediary so that way they can start using it now, where they basically compiled a .NET runtime. Now, what a runtime means, it means running the code real time. So basically an interpreter. Okay, so when you talk about a .NET runtime, it just means that it runs code in the .NET Framework real time and you can see the results right away. Okay, so you can't code, so basically creating a whole compiler may take a long time, but if you can just compile one particular program for now that can do everything you need to do for the time being, that's pretty cool. So that's what they did. So what they did is they compiled that .NET runtime into WebAssembly. So now the runtime can run in the browser. What does that mean? That means that runtime will turn on and they can read all your .NET code and run it real time. Now the downside is it's not the most efficient way of doing things because you have to download the runtime. They have gotten it pretty low. I think it was like 2-3 megabytes versus, hundreds of megabytes versus like a native runtime, which is really cool. But still, when it comes to the internet, you want to be as small with your files as possible because not everywhere around the world has the same speed of internet, have access to the same processing power of computers. So you're always trying to design everything to be sort of small and compact when it comes to the client. Okay, you only want to send them what you need to send them and try to have stuff either happen on their computer or happen off their computer, but not necessarily little as possible that needs to be transferring back and forth, just the basics. But that's a really cool intermediary step, and it kind of shows you what's sort of the power of WebAssembly. So in the future, you'll pretty much be able to use any language to program the front end of the browser. That's sort of the impact of WebAssembly. So we're seeing that with .NET, but you're going to be seeing that for pretty much every other language. You'll see new languages created for the purposes of just programming back and front. And there's people who've done languages like that, where they created a language that can be used on the server side and then has a transpiler into JavaScript. So you can use it for front and back. Things like OPA is a language that's sort of designed with that kind of purpose. But again, it can be even better if you compile it into WebAssembly, which actually I think OPA is doing. I think a couple of those types of languages are not only they have their JavaScript transpiler, but they're now also creating WebAssembly compilers. Very, very cool. Okay, so I just want to introduce you guys to WebAssembly. So those are the 4 technologies that a web browser can use. So if you're thinking about developing a website or learning how to do web development, this kind of presents you very many paths. Now, if you're looking to do this as a career, okay, you're going to be best served by learning HTML, CSS, JavaScript, because that's what most websites are running on right now. And is going to basically be sort of the norm for a time to come, and then basically that's where the jobs are going to be. But if you're looking to create your own website, or you're looking to just do something interesting and innovative, looking at a lot of the WebAssembly stuff, and learning about the different languages around WebAssembly, and trying to see if you can build something cool and new on that technology, that is an interesting space. Or if you're looking to start a business and trying to create the newest sort of create like a new language on top of WebAssembly, or create something that compiles an existing language on WebAssembly, these are things that people would be interested, that there is a market for. Something to think about. But hopefully this gives you a better understanding of those things. Thank you very much. I will see you guys next week.